The world around us is full of dangers. Sometimes we are so busy with our own affairs that we simply forget about it. But as soon as something terrible happens, we immediately understand that we are absolutely defenseless. About 66 million years ago, as Alvarez's hypothesis suggests, a asteroid fell on our planet, after which a shock wave occurred, which killed many dinosaurs. So much dust rose into the air that even during the day it was as dark as night. Due to the lack of light, the climate on Earth became very cold, which caused the complete death of ancient lizards. In many disaster movies, we are shown scenarios in which a space object is flying towards our planet, which is also capable of destroying all life. But what is the reality? Our space journey invites you to find out which asteroids are currently hurtling towards Earth at breakneck speed. What is the danger of such encounters and how to avoid them? Let's find out. According to scientists, a collision with the Earth of a celestial body about 10 kilometers in size, capable of destroying human civilization, may occur in about 100 million years. In the entire history of modern man, such collisions have not occurred for about 100,000 years. Of course, we would like to believe that such an event will never happen, but let's remember whether there were prerequisites for such dangers before. The last of such incidents, which could have resulted in mass casualties, was the fall of the Tunguska meteorite in 1908 in a remote corner of Siberia. It is believed that it exploded about 10 kilometers above the Earth. After that, a glow in the sky and luminous clouds were observed for several more nights. The forest was cut down on an area of 2,000 square kilometers. Scientific expeditions arrived at the site only 15 years later. No significant fragments of the meteorite were found, but microscopic spherules were found, indicating that the substance originated from outer space. Such collisions occur once every few centuries, but there are exceptions. Another event, known as the Brazilian Tunguska, occurred 22 years after the incident described. In August 1930, early in the morning, during the annual maximum of the Persian meteor shower, the sun turned red. Ash fell and there was a roar. Explosions were heard at a distance of up to 250 kilometers. The power of the explosion, despite being compared with the Tunguska meteorite, was incomparable, 10 to 15 times smaller. Several decades later, a satellite recorded an area 1.5 kilometers in diameter with fallen forest. And comparatively recently, we have witnessed a repetition of this terrible scenario on a smaller scale. In 2013, a meteorite exploded at an altitude of 30 kilometers above Chelyabinsk. Glass flew out of windows, injuring 1,400 people. The explosion yielded about 500 kilotons. This is about 30 times more powerful than the atomic bomb dropped by the United States on Hiroshima. Again, the explosion occurred high enough above the ground to avoid serious destruction. But it turns out that such collisions happen much more often, about 3 times a year. Most of them occur over the ocean or in remote parts of the planet, so we usually don't notice them. One of the last large meteorites to attack the Earth was the Kamchatka meteorite. It exploded in the Bering Sea in December 2018. The explosion was recorded by NASA satellites several hundred kilometers from the coast of Kamchatka, and it occurred at an altitude of 26 kilometers from the sea. Over the years of research, it was possible to find out that the collision of the Earth with dangerous space objects does not occur, but they move along the same trajectory, but at different times. At the same time, space researchers note the following most dangerous asteroids, the trajectories of which intersect with the Earth. 1950, Bennu, 1999 RQ-36, Apophis, 2004 Athamin-4, 209 FD, 210 EU, 118. Astronomers rank asteroids on the Polarm scale, a special hazard scale. The most dangerous until 2021 was Apophis, whose diameter is about 325 meters. Its average approach to Earth is about 31,000 kilometers from the planet's surface, about 1/10 of the distance from Earth to the Moon. Scientists have recently found out that the asteroid does not pose a danger in the next 100 years and will most likely fly by. Here is a small near-Earth asteroid 1950 Day from the Apollo group. It is notable primarily for having the highest hazard index on the polar scale. The closest approach to Earth is expected in 2032, and a possible collision will occur in 2880. In this case, human civilization, if it still exists in 800 years, will face catastrophic consequences. Our descendants must be prepared for global climate change and the death of a significant part of the biosphere if we do not learn to prevent such events. Bennu is the next and most dangerous asteroid for our planet. In 2135, it will be only 300,000 kilometers from Earth, which is even closer than the Moon. The date of the possible fall fluctuates between 2175 and 2199. During this period, it will approach Earth at a close distance 78 times. The average diameter of the asteroid is more than 510 meters, and its mass is from 60 to 78 million tons. The impact of this asteroid on Earth would be equivalent to the explosion of a bomb with a yield of 1150 megatons in stratal equivalent. For comparison, the Tsar Bomba, a thermonuclear aviation bomb, the most powerful explosive device ever tested by man on Earth, had an explosion yield of about 58 megatons in stratal equivalent. The asteroid is also interesting because it is the target of the OSIRIS-REx space probe mission, launched by NASA in September 2016. The spacecraft is scheduled to return to Earth with samples in 2023. The next most dangerous asteroid is 2009 FD. It is a binary, that is, a double asteroid. It is a system of two celestial bodies gravitationally bound to each other. They revolve around a common center of mass, like, for example, the components of a double star. Its first component is a body with a diameter of 120 to 180 meters, and the second is 60 to 120 meters. The mass of 2009 FD is about 3.2 million tons. According to scientists, double asteroids have already fallen to Earth. This may be evidenced by some impact craters, for example, the Clearwater Double Crater in Quebec, Canada. 2009 FD flew past Earth on October 29, 2015 and November 3, 2020. The most dangerous period for Earth, when it will be closest to the planet, is 2198. And finally, asteroid 2010 A.U-118, the estimated diameter of asteroid is 1.9 kilometers. This is the largest object included in the risk table of Centria, a collision monitoring system created by NASA. Its specialists constantly scan the latest data on asteroid observations and determine the probability of their collision with the Earth. The most interesting thing is that as a result of software updates, 2010 A.U-118 was removed and then added to this list several times. 2010 A.U-118 makes one revolution around the Sun in 754 days. From 2020 to 2112, 38 purely potentially dangerous approaches were recorded. Well, in 2020, it did not collide with the Earth even once, which is good news. We hope that this will be the case in the future. However, the question is not whether a collision will occur, but when it will occur. Governments of the world are taking this problem seriously and are taking the first preliminary measures to avoid a dangerous collision. The first thing humanity needs to do is build telescopes and observatories. A large telescope can see a space object long before it approaches Earth's orbit. This is how scientists from the Astronomical Institute of the University of Hawaii, who are looking for dangerous asteroids. Now they will also be observing the sky in the southern hemisphere. Their capabilities have been expanded with the help of 2 additional instruments. The Terrorist Real Impact Last Allard System asteroid project has been shortened to ATLAS, funded by NASA. Its goal is to track small asteroids, the diameter of which is measured in tens of meters. One of the new telescopes is located at the Sutherland Station in South Africa. The other is at the El Sauz Observatory in Chile. This arrangement of instruments not only allows you to see the entire celestial region, but also observation points in different time zones allow you to track dangerous asteroids 24 hours a day. On January 22, 2022, the observatory in South Africa announced the discovery of a 100-meter asteroid 2022 BK. Fortunately, it flew past our planet. The U.S. National Aeronautics and Space Administration, NASA, also created the Planetary Defense Coordination Office as the single responsible party for monitoring asteroids. Participants in the European American Asteroid Research Project IDA have even chosen a target for their mission. The automatic station will be sent to the double asteroid Didymos, the European Space Agency reports. The Didymos asteroid consists of a main body with a diameter of 800 meters and a satellite with a diameter of 150 meters, which orbit each other at a distance of about 1 kilometer 100 meters. The IDA project involves sending 2 small spacecraft to the asteroid. One of them will crash into the smaller asteroid at a speed of about 6.5 kilometers per second, and the second will conduct observations. Scientists expect to record changes in the orbital motion of the 2 bodies that occurred after the impact. Scientists emphasize that the goal of the project is not to develop a technology to intercept dangerous asteroids. But this is the first step towards such a technology. In 2014, the Japanese Space Agency launched the Hayabusa 2 spacecraft into orbit around the asteroid Ryugu, and 2 years later, the United States launched the OSIRIS-REx Automatic Interplanetary Station into orbit around the asteroid BMNU 1999 RK-36, which landed on the asteroid in 2019. In total, more than a dozen projects, including ground-based and orbital vehicles, are searching for potentially dangerous asteroids. A large number of observers and their unification into a single network make it possible to achieve very impressive results. In March 2022, a 5th asteroid was discovered before it fell to Earth. On March 11th, Christian Czarnecki, a geography teacher and asteroid hunter, noticed a new moving near-Earth object in his photographs. He reported a discovery in the center of minor planets. At first, the probability of a collision was estimated at 1%. However, a couple of hours later, the European Space Agency's Mearcade system sounded the alarm. More accurately calculated parameters of the body's orbit indicated the inevitability of a collision. Despite the difficulties of detecting the body, which was already closer than 50,000 kilometers from Earth and moving quickly across the sky, additional observers joined the search. It turned out that this meteorite was about 100 meters in diameter, which was supposed to enter the atmosphere near Iceland. And this is what happened. The flash was recorded by cameras in Norway, and the fall was confirmed by a network of infrasound detectors. But telescopes alone are not enough. It is necessary to mobilize forces to create a powerful technological invention, for example, a laser gun or a rocket gun, which will be loaded with nuclear bombs that will turn the space object into dust. At the current stage of development, various methods of combating steroids are being considered. NASA has come to the conclusion that with the help of nuclear implosion, it will be possible to push away near-Earth objects with a diameter of 100 to 500 meters if they are detected 2 years before the fall to Earth, and larger objects if they are detected 5 years before the fall. Another method is to send a huge object like a spaceship or even another near-Earth object as a battering ram. Or, for example, a gravitational jerk of an asteroid. Another alternative to an explosion is to slowly move the asteroid over a certain period of time. Over time, the small constant thrust builds up and deflects the object sufficiently from its intended course. But the non-contact method is slightly different. A proposal is to use a low-divergence ion cannon aimed at the asteroid from a nearby ship. The kinetic energy transferred through the ions reaching the asteroid's surface, as in the case of a gravity tug, would create a weak but constant force. A ship capable of deflecting the asteroid, but at the same time lighter, would be used. An alternative would be focused solar energy. It is proposed to deflect asteroids or comets by focusing solar energy on their surface to create thrust due to the resulting evaporation of matter due to heating, or to enhance the Yarkovsky effect, a weak reactive impulse due to thermal radiation. Solar radiation could be directed at the object for months or years. An electromagnetic catapult is also recommended. An automatic system located on an asteroid that launches the substance it is made of into space. In this way, it slowly shifts and loses mass. An electromagnetic catapult should work as a low-specific impulse system. Use a lot of fuel but little energy. Another possible way to place an electromagnetic catapult on the moon is to aim it at a near-Earth object. And perhaps the most logical way would be to install rocket engines on an asteroid. Conventional rocket engines are installed in near-Earth orbit, which can create a permanent deviation of the celestial body. Whatever method is chosen in the future, its effectiveness will cost the lives of all mankind. In the meantime, the main thing we must remember is that if you hear a media report that a terrible asteroid is about to fall, the most sensible thing to do is to open the NASA Near-Earth Object Center or ECO Near-Earth Object Coordination Center website and look for the asteroid there. Usually this simple action is not very encouraging. Either the rock is small, or the date of potential approach is in the middle of the millennium, or the probability of collision is ridiculously small, or all of these combined. In general, despite the fact that a body the size of the Chelyabinsk meteorite can arrive unexpectedly, large asteroids have already been found for the most part, and humanity is actively and successfully working on cataloging potentially dangerous objects. Not a single person knows the boundaries of our universe, but regardless of whether it has a limit or not, it hides many secrets and oddities. Scientists from all over the world are busy studying objects that continue to expand our knowledge of the structure of the universe every day. And sometimes in their research they encounter very strange objects that at first glance contradict the known laws of the universe. Let's find out about the strangest objects in the universe. Dark matter. Dark matter, one of the greatest mysteries of modern astrophysics, is a hypothetical matter that cannot be seen with telescopes. However, it is believed that approximately 85% of the matter in the universe is dark matter. It does not emit electromagnetic radiation of sufficient intensity to be observed, but it can be observed by gravitational effects. As is known from the laws of gravity, the rotation speed of galactic objects and galaxy clusters depends on the distance to the center of mass and the distribution of mass inside. Comparing known formulas and astronomical observations, a paradoxical result was obtained. The masses of galaxies are much greater than we see. Next are quasars. Classified as an active galactic nucleus, quasars are essentially an extremely bright disk of matter surrounding a black hole. Quasars are considered the brightest known objects in space, capable of shining 100 times brighter than their entire gravitational path. Giant water reservoir. A huge cloud of water vapor located about 10 billion light-years away contains about 140 trillion times more water than all the oceans on Earth combined. More precisely, we are talking about the shell surrounding the quasar and containing water vapor. The region around the quasar is about 100 light-years long. The environment of the quasar is unique because it contains a gigantic mass of water. This once again shows that water is widespread in the universe, even in very early times. A giant ancient black hole. This discovery was made by an international team of researchers in 2015. A gigantic ancient black hole was discovered that powered the brightest quasar in the early universe, located 12.8 billion light-years away. The black hole itself is 12 million times more massive than our Sun, and the energy absorbed by the quasar is a quadrillion times greater than that of the Sun. The quasar itself was created just 900 million years after the supposed Big Bang. According to all existing models, it is unclear how the black hole was able to accumulate such an incredible mass in such a short period of time. A pulsar is a dense, highly magnetized, rotating neutron star that emits a beam of electromagnetic radiation. In the past, astronomers believed that the radiation, which can be seen if it is directed at Earth, was an alien form of communication. In 2020, astronomers from the United States and Poland discovered that the reason this type of neutron star acts like a radio beacon is because of the interaction of electric and magnetic fields near the surface of the object. Orphan planets. Orphan planets, also known as wandering planets or quasiplanets, are planetary mass objects that have fallen out of their orbits and are drifting aimlessly through space. The closest orphan planet to Earth discovered to date is 7 light-years away. Almost nothing is known about this mysterious object, neither how it came to be nor what happened to its star. Scientists have discovered that the planet is very young and is only 12 million years old. It is a gas giant with a mass 6 times greater than Jupiter. This celestial body is located 80 light-years from Earth. Scientists have never seen such an object floating freely in space before. The planet can be observed with a telescope. Experts estimate the surface temperature at plus 885 degrees Celsius. The hot, icy planet, officially known as Gliese 436b, is a Neptune-sized exoplanet orbiting the red dwarf Gliese 436. Despite the planet reaching temperatures of plus 403,109 degrees Celsius, its water surface does not evaporate. Instead, the molecules form a kind of hot, highly compressed summer. Pillars of creation. The pillars of creation, which look like a sci-fi landscape, are actually photographs taken by the Hubble Space Telescope in the Eagle Nebula, located 7,000 light-years from Earth. The pillars, made of cooled molecular hydrogen and dust, are essentially the seeds of new stars. The objects were named pillars of creation because the gas and dust in them are involved in the process of forming new stars, as well as in the destruction of clouds of color from already formed stars. Shooting stars. Everyone probably knows that what we call shooting stars are actually meteorites falling through the atmosphere. But shooting stars do exist. For example, Mira is a red giant that is falling through the galaxy fast enough to develop a tail similar to what we see on comets. Astronomers were quite surprised. The thing is, the world has been studied for 400 years, and until now no one has noticed anything particularly strange about it. However, this can be explained quite simply. No one has observed it in ultraviolet light. The detected tail extends into space for a whopping 13 light-years, which is almost 3 times the distance to the nearest star to the Sun, Proxima Centauri. Diamond Planet. The Diamond Planet, officially known as 55 Cancri I, Cancri E, has a mass that is 7 and 8 times greater than the mass of Earth. This planet is believed to contain huge deposits of coal, which may be in the form of diamonds. According to Forbes calculations, this planet could be worth about $27.0 million, which is about $27.0 million on June 27th and 30th. The giant diamond planet was once part of a binary star system until its partner began gobbling it up. However, the star was unable to take its carbon core with it, and the carbon simply turned into diamond under the influence of high temperatures and gigantic pressure. With a surface temperature of 1,648 degrees Celsius, the conditions were almost ideal. A third of the planet's mass is pure diamond, while Earth is covered in water and rich in oxygen. This planet is made up of graphite, diamond, and several silicates. Frozen star. While most known stars are very hot, with the sun's surface temperature reaching 5,600 degrees Celsius, a cool star has recently been discovered. The frozen star, officially known as WISE 0855-0714, is a brown dwarf with temperatures ranging from -48 to -13 degrees Celsius. In 2016, astronomers from the University of California, Santa Cruz, using the Gemini Observatory, discovered clouds of water and water ice in the star's atmosphere. Scientists from the University of Edinburgh calculated that the star's atmosphere contains a 100-kilometer thick layer where the temperature remains between -73 and -23 degrees Celsius. The air density ranges from 0.4 to 1.2 milligrams per cubic centimeter. According to them, organic life could originate in this layer. The largest Fermi bubbles of gamma radiation. In 2010, astronomers discovered a rather strange phenomenon in the data of the Fermi Space Observatory. Two giant spherical structures about 50,000 light-years in size burst out of the center of the Milky Way into the surrounding space. These formations are visible only in the gamma-ray range. The nature of the bubbles is still unknown, but scientists suggest that they could have formed as a result of the activity of the supermassive black hole in the center of the Milky Way. At the dawn of our galaxy's life, its active nucleus ejected plasma streams, so-called jets or relativistic jets. The Fermi bubbles are probably a kind of trace of these streams. Supervoid. The Eridanus supervoid. Most of us probably think of space as empty. However, with the discovery of quantum physics, we know that even empty space is not actually empty, but it contains trace amounts of gas, energy, and virtual particles that appear and disappear. So it is still quite surprising to find regions of space that are almost completely devoid of all types of matter. The largest of these voids is in the constellation Eridanus. It extends over a region of space equal to 1 billion light-years. Many physicists have put forward some very interesting theories about the origin of this void. One of them says that the void is the imprint of a parallel universe that collided with it in the distant past. Another says that this region may be home to a black hole. A gas nebula called a soap bubble. A beautiful symmetrical nebula floats in the area of the constellation Cygnus. It was discovered only a few years ago, so it is not included in many astronomical atlases. The most amazing thing is the shape and appearance of the nebula. It resembles a real soap bubble, and this is the nickname scientists gave it. Witch Head Nebula. The real name of the nebula is IC 2118. It is located in the southern constellation Eridanus, 1,000 light-years from the Sun. The most amazing thing is its outline, resembling a witch's head. We see nebulae behind the stars Rigel. Thanks to its radiation, the outline of the witch's head is reflected and visible in telescopes from Earth. Conclusions. To summarize, the observable universe contains about 10 million superclusters, 350 billion large galaxies similar to the Milky Way, 25 billion galaxy groups, 7 trillion dwarf galaxies with trillions of stars. And this leads to the idea that many more strange objects in the universe remain unknown to us. So there you have it, folks. A mind-boggling journey through some of the most massive objects in the cosmos. From colossal black holes to supergiant stars, the universe is full of wonders. And that's just a tiny glimpse. If you want to explore more cosmic curiosities, make sure to hit that like button, subscribe to the Curiosity Dude, and turn on those notifications. We've got plenty more mind-blowing content coming your way. Thanks for watching.